Okay, so this is a last problem, discussion problem on electrochemistry for this week, week number 10, and that's number 4. And this is something called electroplating. And I want to show some like a schematic diagram picture, just looks like that. We are talking about, in this problem, we are talking about H2CrO4, which is chromic acid, so metal deposition case. But I was able to find something that is more similar, electroplating on the copper. So here's an example of where you can see that you have, for example, is a copper sulfate solution. So copper 2 plus and the sulfate are dissolved. It's this kind of bluish one. And then you can put the and this is just like previous one. This is a electrolytic cell, right? So you apply the batteries, and the negative charges, the electrons are being supplied, and this is a negative terminal. Cathode is a reduction reaction is happening. That reduction is copper 2 plus is getting 2 electrons from the electrode and deposit on the surfaces on the copper. So as you can see that the picture shows on the surface of any metals, and the surface is now coated with shiny copper metals, and then the other side is you can put the other one, and then this here is essentially copper so depleted or dissolved back into copper 2 plus, because that's where the oxidation in the anode side, right? So in these cases, you can imagine that so this is an example, 1 moles of copper needs 2 moles of N2. So in this case, N is 2. As you can imagine that there are 2 electrons are involved in this. And the other one that I also find out is this is an exam reference sheet, and the Q is a charge of an electron, right? A is a current. You know, the current is we are using the unit of ampere, and we are using the unit of coulomb as a C, and the T is just the time. Time is just the second, right? So the ampere is coulomb over second, right? So that's the concept that also you want to remember, not to forget about it. And also, let's see. So let's look at the problem. Okay, so let's read the problem. What current would be required? So they want to know what will be the current, right? In terms of ampere, right? So what current do I need to deposit the surface? This is a surface area, so I guess that's a surface area of 1 square meter, which is pretty big. A chrome plate having a thickness of 0.05 millimeters. So this is a one, and they want the chrome to be plated here, and 0.050 millimeter. And in other words, this is about 50 micrometer. Okay. And so, and then what they give it us is density of the chromium is 7.19 gram per cubic centimeters, right? So then, as you can see, that on the substrate, when you apply the negative voltages, there will be a essential deposition of chrome metal from the solution. In the solution, you will see that from chromic acid. So the chromic acid has a chrome 6 plus. Okay, so that's so important to know. Okay, H2CrO4. What am I doing here? That's a plus 2. This is a minus 8 because oxygen is minus 2. So therefore, I ended up getting plus 6. So this is a chromic, which is Cr6 plus. So Cr6 plus, you need 6 electrons, and then that will be deposited into chrome metal. Okay, so that's a chrome plating. So let's do this one by one, and once again, I think that I mentioned this one once again, the concept about Faraday constant. This is important, so I want to emphasize one more time. Okay, Faraday constant. Faraday constant has a 96500 coulomb for 1 moles of electron. It's nothing but when you have a 1 moles of electron, Avogadro's numbers of electrons there, this will be their charges. Okay, charges of electron when you have that. That's a ratio between these two, and that turns out to be an important one to figure this one out. Okay, so what is a question? What was being asked in the question now? Okay, so I want to deposit in, and then they want to say, okay, this many hours are being used. So that is essentially 4.6 hours can be 4.6, 3600 seconds, right? So that can be turned that current ampere into a coulomb. So I guess now is really coming down to calculating Q, which is a charge of an electron needed for in terms of unit of coulomb, needed to be for electroplating. Okay, so then we start from here because we know the volume. So what is the volume here? Volume is, okay, so the volume. This volume is 1.00 square meter times 50 10 to the minus 6. So that's 5.0 10 to the minus 5 square meter. Okay, so that's my volume. And what's my density? So this is my density, but I want to use a volume as a meter square. So that's a 7.19 gram. 19. And this one is 10 to the centi means the 10 to the minus 2. So that becomes 10 to the minus 6 gram per cubic meter. Okay. So this many grams, which is a huge number of grams, in the cubic meters, 2 to 3. Okay, so let's start with the volume. So I have a 5.0 10 to the minus 5 meter square. That's a volume. And then I want to change that into 7.19 10 to the minus 10 to the plus 6 gram per cubic meters. And this will allow me to essentially up to here. This is a chrome gram, right? So chrome mass. That how much chrome mass do I need to deposit for the electroplating? And this is gone, and I ended up now the chrome gram, right? So then I want to multiply this by, I guess, the atomic mass of chrome. That is 52.0 gram per 1 mole chrome. So that means I want to put grams of chrome, moles of chrome here. So 1 mole should corresponding to 52. And so that I can do this deletion. So I just up to here now is this unit conversion. Now chrome mole, right? So I know how many moles of chrome do I need to use it. And then what do I need? Is here I need to use moles of chrome and moles of electrons. How many do I need? And as you find out from here, this is a 6 plus chrome. You need a 6 electrons. So 1 moles of chrome need a 6 electrons. Okay. So if you want to be super critical about super careful about it, you guys can think about that way as well. But at any rate, 1 to 6 ratio between chrome atoms and electron particles, right? So by doing so now, I'm getting there really, right? So that's the number of moles of electron. And then at the end, what do I really need? Now, my final punchline is, hey, I want the coulomb of charges, right? From that many electrons, right? And the answer can be found out. What do we know about this? 1 moles of electron, 96500 coulomb, right? So by doing so, I can get that, and I'll ended up having these simple answers. So therefore, what I have is charges that you need is 4 times 10 to the 6 coulombs, right? And an ampere is essentially coulomb times T, coulomb over T, right? Coulomb over T. So now you're going to 4.00 10 to the 6 coulomb. And how many times? That was a 4.6 hours, 4.6 second, right? And then you will see that becomes 247 angstroms, that means 247 coulomb per second, and that becomes this answer is right here, right? So that's what's the current do I need? Because you need to say, well, I can calculate the charges that has to be, the number of electrons that I need to use, but that has to be consumed within 4.5 hour time window. That means this is a current. This is an enormous number of current, okay? So electrochemistry, but it is unuseful, as you can imagine that from this chromic acid solution, you actually reverse the reaction, so that we can deposit this metal on the surfaces. So we can coat any metals and then make these things having shiny surfaces from the metal. That is very thin, okay? 50 micron is a pretty thin layers of film can be deposited. And that's what we call the electroplating.